Alright class, today we're learning about summation notation. It's basically to find the sum of terms in a sequence. We can write out the terms and add them up to, or we can use the Greek letter sigma, which looks like this E thing here, to indicate, to find the sum of the terms. So if I say, the first term plus the second term plus the third term plus all the way to the nth term, that can be written as a sub k, where k starts at 1, because we started at 1, and ends at n. Okay, so let's see how this works with actual notation. So this is telling you that the sequence is 2/3 of the k, and we want to start here. They're starting us at 0 and going to n. So this means that the first term we're going to put a 0 in, plus, because remember sigma means we're adding these together, 2/3 k now is the first to the first, plus 2/3 to the second. Now here's the thing, because we're going to n, that's a letter, so it goes on forever, so we don't need to keep going. We only need like 3 at the front, and then I'm going to end with the 2/3 to the n, because that's where it's going to finish, whatever n is. And then to simplify, this becomes a 1 plus 2 over 3 plus 4 over 9 plus dot 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 plus, and this is still 2/3 to the n. So that's how you write out that summation. Now sometimes it does end. Number 2, it does not. We're still going to write this one out. Again, this tells you your starting point. So we're plugging in 2 first for k. Alright, so I'm plugging in 2 first. Now I'm plugging 3 in for k. Now I'm plugging in 4 for k. Now I'm going to dot 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 it and then plug in n for k. This is 6 minus 1 is 5, plus 9 minus 1 is 8, plus 11, plus dot dot dot, plus 3n minus 1. So that would be the summation expanded out. Now sometimes I do actually have a stopping point, like number 3. So number 3, we can actually expand it first and then actually find what the sum is. So here I go, expanding it, negative 1 to the 0, times 2 to the 0 plus 2. Plus, remember, with this sigma, every time you do the next number in the sequence, you're adding them. So we get negative 1. Obviously, if a minus sign pops up, though, then it'll be subtraction. Oh, this should be positive. I don't know why I put minus signs with the powers. They don't need, I think because I was talking about minus signs. Times 2 to the 2 plus 2 plus negative 1 to the third times 2 to the 3 plus 2 plus negative 1 to the fourth times 2 to the 4 plus 2, and finally plus negative 1 to the fifth times 2 to the 5 plus 2. So what this turns into is 1 times 2 squared, which is 4, plus, well actually, okay, it's going to be a minus actually, because negative 1 to the first is a negative 1 times 2 to the third, so this becomes a minus 8. Then we get a squared, so the negative 1 goes positive. 2 to the fourth is 16. This next one, it's an odd power for the negative 1, so it's going to be a minus. And then we get 32. This one's going to be a plus with the 4. 2 to the 6th is 64. You should also see the pattern here. It's going up by a multiple of 2. And then the last one's going to be minus, because it's an odd. And then 2 to the 7th is 128. So this would be an expanded form, and then we can actually solve this. If you add all those together, you get it's negative 84. So this value here is negative 84. Alright, now we're going to do the opposite. We're going to go backwards, try to come up with the summation notation. It's very similar to what you did yesterday with the nth term. You want the nth term basically formula, but we're using k's, okay? So clearly this is going up by 3's. So just like yesterday, when we went up by 3's, that's like multiplying n times 3. So I have 3, except we're using k now. However, if I put a 1 in for k, I get a 3, not a 2. So we have to add something on. So we add minus 1. Let's double check that this works. Put a 1 in, you get a 2. Put a 2 in, you get 6 minus 1 is 5. You put a 3 in, you get 9 minus 1 is 8. So this is the formula that we're going to use. And now we're going to add our summation signal, or sigma, which is our summation symbol. and we're saying that k is going to start at 1. We're putting a 1 in first, and then which term do we go to? We go to the 5th term. So that is our answer. So it's kind of like what we did yesterday, but we're adding on now the sigma with where we start and stop. All right. This one we have to figure out, because this is 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. So it's kind of like the one we just did, actually, up above. Correct? Yeah, it's pretty much the one we did up above, except for that one started at 0. So we have to figure out 2 to the 7th is 128. 2 to the 8th is what, 256? And this is 2 to the 9th. Okay, so that's where it ends. So we know from up above that this formula is 2 to the something. And it also has a negative 1 to the something. We'll deal with that in a second, because it's alternating signs. So k is starting at 1. So that gives us 2, but we want a negative 2, so we do want this to also be k, because we want it to be an odd number when it's 2. And then we're ending when k is 9, and we found that out right here. That's what 9 is. So again, figure out the pattern and then figure out how far you have to go. Okay, another alternating one. So we're going to have to do a negative 1 to something, but we'll worry about that later. It looks like the top doesn't even change, no change, so it's going to be 1 over something. And the bottom you can think of as going up by 1s, so you can just put a k here. Times negative 1 to the something. And we'll deal with that in a second. So k equals 1. Now if k equals 1 and I put a k here, I get a negative, but I don't want a negative there, so I'll say k minus 1 for that thing. You could also do k plus 1. So that's negative 1 to the k minus 1 times 1 over k. K goes from 1 to where? Well, if you look at this, notice how it just says dot dot dot. It doesn't have any ends. It doesn't have anything. That means it's going to go on infinitely forever. So we're going to put an infinity sign on top. This one we have to figure out the pattern. Excuse me. Hopefully you guys recognize that this is like 2 squared, 3 squared, 4 squared, 1 squared, dot dot dot. So the number that's changing now is what your k will be. So this is k squared. We're going to start that when k equals 1, because that was the first one. And then again, since it's going on forever, we're going to infinity. So those are our values for those. Okay, these next two are kind of like what we did with recursive. It tells you where to start and how to do them. But I want the sum now of the first 5 terms. So first I'm going to find the first 5 terms. There's the first term. The second term is equal to 2 times, remember what this means. This means the previous term. So the previous term was 2 plus 1. So we get 4 plus 1 is 5. Then a sub 3 is 2 times the previous term, which was 5, plus 1, which is 11. A sub 4 is 2 times the previous term, plus 1, so that's 23. And a sub 5 is 2 times the previous term, plus 1, so what is that, 46, 47. So now I just need to add those together. 2 plus 5 plus 11 plus 23 plus 47. And you get the sum of the first 5 terms is 88. Okay. You can pause this one and try to do this one on your own. And then when you're ready, you can come back if you want to. So this one again, this is the previous term right there. So, and then this is n. So this is the term that matches the term you're on. So a sub 2 is equal to the previous term, which is 4, over 2, plus 10 times we're on term 2. So we get 2 plus 20, which is 22. A sub 3 is equal to the previous term, which is 22 over 2, plus 10 times we're now on the third term. So you get 11 plus 30, which is 41. A sub 4 is equal to the previous term over 2, plus 10 times n, which n is 4 because we're on the fourth term. So 40 plus 20.5 is 60.5. And then a sub 5 is equal to 60.5 divided by 2 plus 10 times 5. So that's 50 plus that, and you get 80.25. Again, to add the first 5 terms together, you just add them once you have them. So really this did not change much from yesterday's notes with the coming up with the first 5 terms recursively. Now we're just adding the terms together. So you get 207.75. Okay, so that's the answer. Here we go. This is where it's a little tricky. I think this is the hardest thing you guys have to do, and there's not going to be a lot of this, but because when we do arithmetic and geometric sequences, there's formulas for those that always happen. So this you're going to have to figure out. So write a recursive formula for the sequence of numbers. So remember, recursive means you need a starting point. Well, clearly the starting point for this one is -2. Then you have to figure out what's happening. This one's a clear +4. So the nice thing about recursive is you take the previous term, so a sub n is equal to the previous term, which we're going to write n minus 1. And then what are we doing to the previous term? We're adding 4. And that's it. That is the recursive formula for that one. We're taking the starting point at -2, and then we're adding 4 each time. This one's a little challenging. This is an adding of 6, but then this is like, what is it? 29 minus 11 is what? 18? Yeah. And then 83 minus 29 is something really big, 54. Okay, so there's not a clear pattern there. So let's try multiplying by the previous term. If we do 5 times 2, we get 10. I'm just guessing things here. And then to get 11, we do +1. So is it the previous term times 2 plus 1? Let's try that one. So if I take 11, 2 times 11 is 22, plus 1 is 23, which is not 29, so this is not correct. So let's try another way to get from 5 to 11. Let's multiply by 3. This is honestly what I would do. I would just kind of play around with it. So 5 times 3, so let's try 3a sub n minus 1. So if I do 5 times 3, I get 15. But how do I get down to 11 then? I have to subtract 4. So let's try this one now. So we know that when we put a 5 in, that gets 11. If I do 11 now, and then minus 4, what do I get? I get 33 minus 4, which is 29. Okay, that's our next number, so that's good. Let's try it one more time to make sure we have the right pattern. 3 times 29 minus 4 is 83. So this is the pattern here. So to write a recursive formula, you need a starting point of a sub 1 equals 5, and then you need a sub n equals 3 times its previous term minus 4. That one you got to just play with. So you either multiply, if it looks like it's going up by a lot, I would multiply by a number and then figure out how much you need to take off of it and see if it works. So we tried 2 first and then adding 1. That didn't work, but multiplying the previous by 3 and subtracting 4 does work. Okay, so that is summation and then some extra stuff with summation.